Hey there. Just going to run through this 2016 higher level question, section C, question 3, for you. Tricky little question. Just going to do part of it and just talk through it. The hedral angle I'm assuming you're going to be okay with, so I'm going to leave that out for the moment. If you have problems, you know to get me. So basically they tell us that we've got this box that has a square base, a circular round top, and the circular top is joined to the square base by these straight line elements that run from the circle down as far as the bottom. Okay, and they're just in the question, they call them straight line elements. So what you need to notice on the question is that the circle is split up using your standard way of splitting up a circle for equal spaces, so 30 degree, 60 degree lines. In this case, that's going to mean you have a horizontal, vertical, a 60 degree and a 30 degree to break it up. Okay, if you were looking trying to figure it out on the question itself, they do show light lines to show that it is 30-60 that's been used to break up the circle. Okay, so that gives me my points E, F, G and H. I haven't bothered indexing the ones around the back. They're on the circle, so they've been brought straight up to give me E, F, G and H in front elevation. Okay, the outer limits of the circle, there and there, they're just given the full width of the circle from there to there in front elevation, which is just appears as an edge view. Okay, the square, C being the outermost point there, D being the outermost point there, A at the front. I haven't even bothered joining up the one at the back yet. Okay, so one of the first things you're asked to do then is to get a development or a true shape of the surface ACE or AEC, whatever you want to call it. That's the surface running from here up as far as here, back down to here in front elevation. A up as far as E, back down as far as C. Okay, in the plan, that surface is standing straight up here off the page. Okay, so it appears as an edge view. So I can look in 90 degrees to that edge view, set up my x1, y1, which is going to be set up parallel to that, so it's at 60 degrees. Bring up my point A, my point C, and my point E. Okay, plan, going to an elevation, plan, going to an elevation. So I've taken my heights from here, or just go current view, last view, second last view. So the height from the XY up as far as point E here is 125. I know that from the question. So the height up as far as E here is also 125. A joins to C, joins to E. A and C are on the ground. They're still on the ground. E is up 125. Join that together. That's the true shape of surface ACE. Okay. That would also be the true shape of the surface A, H, and D, which I haven't joined in, and the other one on this surface and the other one here. Okay, so that would be the same shape for each of them. In the next bit of the question, they ask you to complete a development of that transition piece. So basically this surface running around as far as H, and I'm going to run through that now. So to do that, they've also asked you to get the true length of the line, straight line element AF. Okay, so just remember, because AF isn't a horizontal line in plan, it's not true length in elevation, because obviously it's not horizontal in elevation, it's not true length in plan. So that line is sitting at an angle. Okay, what we're going to do with that line is rotate it around to horizontal in the plan. That way I'm looking in at it this way at 90 degrees in the elevation, it'll appear as a true length. So in the plan, I've done two options, and I'll send the pictures, close-up pictures of this on as well. You can either rotate about point A and take F onto a horizontal line there. So there's AF just rotated out parallel to the XY or to the vertical plane. I'm now looking in that direction. In the front elevation, point A is going to stay in place. Point F has rotated as far as here. That would be point F. If I join A up as far as F, which just happens to coincide with E, that would be the true length of that. Okay, I just did it a second way just to actually let it be seen a little bit easier. So rotating about point F, A gets rotated back as far as there, so there's it rotates to a horizontal position. A moves straight up, and A moves horizontally in the front elevation. So each of these points, I've made a note down here, the rotation of the plan and then move horizontally in the front elevation. So A has moved out as far as here, joins back as far as F. There's the true length of AF from there as far as there. Okay? So after you've done that, you need that piece of information to do this bit. And remember, a development is essentially a true shape. Okay, so you have a true shape of each of these surfaces. They happen to be joined together. I should have dotted lines on these really for full lines, but this is okay this way. So there's the true shape of that piece. I basically need the true shape of my orange section, my blue section, and the green section, green triangle. Okay, so I know the true length of A as far as F is this length up here. A as far as F, that's my true length that I've just found. It says moved here, so I'm going to set it properly. So there's the true length of the line AF. So bring that back as far as there. Okay, true length of that. I am taking that and swinging it from A up as far as there. Okay, so that's the true length of that. The second thing I've done, this distance from E out as far as F, the true length of that comes from the distance from E to F in plan. Okay, that surface is horizontal in front elevation, so each of these edges are true lengths in plan. With a development of a cone or a development of a cylinder, we always just step off a straight line distance for that, for each of those. So basically I put the point of my compass at E, open as far as F. Okay, it's going to be set the same if I set it from E as far as, or F as far as G and G as far as H, because they're divided evenly. So that's what the compass is set to. Put the point of the compass at E and swing an arc across. Where that arc crosses the other arc, that gives me the location of F. That just joins out as far as there. That joins back as far as there. Okay, I then get my distance of AF, which is going to be the same for AG. Point the compass at A, swing an arc up at G. My other distance, F, swing an arc out to intersect that arc. That gives me the location of G. Okay, and then finally this piece, the distance for A as far as H is back on the edge of the other larger triangle again, A as far as H. It's going to be the same length as A as far as E. Okay, so the first edge. So that distance is A up as far as point E. That's the distance marked out there. Compass set to the shorter distance again and marked off the same as the rest of them at that location. And where the two of the marks intersect, that's the location for H. So again, this distance is the same as that distance, is the same as that distance, each of which have been marked off between two of these points in the plan. Okay, that length is the same as the true length over here, which is also the same as that one, because those two lines are going to have the same length. They're going from A as far as F and A as far as G. They will have the same length. And as I said, that line AE is going to have the same length as AH. Okay, and that gives you your solution. You can do like they've done in the actual question itself. You could go and take that and just draw it out flat like that. Doesn't make any difference. Just what's done up here is just that projected that way. Okay, and that's how you get that transition piece. So have a look at it. I'll send on the close-up pictures of some of the steps involved in doing that, and you can let me know what you think. Okay, thank you.